What would it take to control a star? Especially one that, according to science, shouldn't exist. Every so often, one single star in the sky, Tabby star, does something unthinkable. It twinkles. No, really, I mean dramatically twinkles, like we have never seen before in the entire universe, losing a fifth of its inner light at random intervals without warning, as if something massive is blocking out its light. When astronomers first saw it, they tried out every explanation. Dust debris, instrument error, none of it fit. For a moment, some scientists considered a possibility they almost never say out loud. What if something out there was powerful enough to harness a star? But that's the wrong question. Because long before we had telescopes, we were already imagining what it would mean to control the sky, to harness the power of our own sun and bend it to our whim. An old story about a demigod from the Pacific Islands who did something impossible tells of capturing the sun as it raced across the sky. That same question captures us today, as we ask not what's out there, but how much power a civilization, how much power we could ever truly possess. Is it really possible to control a star? What's the true future of our technology? And what limits are there really to being human? Join me as we unravel all this and much more and enter the Codex Legendarium. I'm Shelby Melanson. Far out into the cosmos, around 1,500 light years away from home, there is a star. But the thing is, it doesn't seem to have gotten the memo that it's a star. Hear me out. We here on Earth like to think that stars twinkle. The thing is, they actually don't. The twinkling that we see is because of light getting bent as it comes into our atmosphere. So basically, it's an optical illusion. The exact amount of light that a star emits can actually vary during the whole course of its life. But keep in mind, the average star lives for about 10 billion years. So this twinkling is not something we're going to really witness ourselves. But actual twinkling would only happen if the star was super bright sometimes and got dim other times, which isn't how it works. Why then is there one particular star in the night sky that is twinkling for real? Tabby star, officially named KIC 8462852 and located in the constellation Cygnus. And every once in a while, totally at random, it gets anywhere from 5% to as much as 22% dimmer. In the words of theoretical physicist and futurist Dr. Michio Kaku, now that's incredible.
Now that's incredible. Stars don't simply diminish by 20% in intensity.
Dr. Kaku is clearly having a good laugh about this, but let me explain for the non-astrophysicists out there, myself included, because it kind of sounds like no big deal, right? Planets orbit stars and block out a bit of their light while they pass in front of them all the time, right? That's literally how planets are discovered. But not this time. Let me put this in perspective. If a planet the size of Jupiter, as in supermassive, were to orbit Tabby's star and pass in front of it, it would block out roughly just 1% of the star's light for maybe a few hours for every X amount of days. Okay, maybe then there's just some unimaginably big planet out there that's passing by Tabby's star. Nope. That possibility's out too, because planets orbit in predictable timed patterns. Tabby's star gets dim at totally random intervals for anywhere between 5 and 80 days at a time, and the level of dimming is also random. So it's as if God himself plugged a gigantic dimmer switch and wants some mood lighting every now and then. We first discovered the unusual display back in 2015. That's when astronomer and Professor Tabitha "Tabby" Boyajian and her colleagues at Yale launched a program called Planet Hunters. Basically, the goal was to take years' worth of star data from NASA's Kepler mission and get a bunch of amateur astronomers to scan it by eye for trends and patterns that computers might miss. The human brain is super gifted with recognizing patterns, which any astronomy nerd will tell you is critical for finding big discoveries in space that kind of look like small specks via telescope data. The Kepler mission, which we've talked about on this channel before, by the way, so if you haven't seen that one, go check it out. But basically at the time, the mission had collected images of 150,000 stars every 30 minutes for 4 years, meaning it gave us a unique snapshot into the behavior of space objects over the long term. And one of those amateur astronomers, named Adam Shefchik, noticed that something was amiss with one star in a way that no other explanation could account for. It was so weird and unbelievable that Dr. Tabitha expected to find some kind of error with the data or the Kepler telescope itself as the cause, rather than believe that the data was real. 1 year and an over $100,000 Kickstarter project later, 1,700 backers rented a network of telescopes to observe Tabby's star. The Las Cumbres Observatory even donated 200 hours from its telescopes in Hawaii and the Canary Islands to help. And by late 2017, it was clear Tabby's star had started to dim again, and we have no idea why. There have been a ton of possible explanations thrown around here, but none of them really stick. NASA wrote in 2024 that it was probably just an uneven ring of dust around the star causing the weird light show. Others have suggested Tabby's star could be in the process of swallowing a planet or a moon, kicking up a clump-filled cloud of space dust. While a handful have suggested we could even be looking at a Dyson sphere, an artificial megastructure used to harness the energy of an entire star. More on that later. Here's the thing. Whatever is happening would require an enormous object and/or unimaginable amounts of energy. And for a moment, some of us may have wondered if something out there was powerful enough to control an entire star. But if you ask me, the real question isn't what or if something is out there doing that. It's whether any civilization, whether our own civilization, could actually ever harness and wield that much power. Tabby's star, albeit one of the most unusual, is not the first thing that has ever made us wonder about what the actual limits of harnessing energy could be. It was definitely on the mind of one Soviet astronomer named Nikolai Kardashev back in 1964, for one. Now, this was right around the same time that scientists started scanning the sky for radio frequencies, just in case anyone out there might be trying to get a hold of us. But again, this is not about the presence or lack thereof of extraterrestrial life. In fact, according to Kardashev, it's about two things: energy and technology. More specifically, what the energy and technology of a civilization and their radio frequencies could look like at much, much more advanced stages of development. Not to mention the vast distances that those frequencies might be able to travel. Something that, in his words, quote, may be comparable to or even more enormous than the dimensions of our galaxy. His theory, the more energy a civilization can produce or harness, the higher its technological advancement. So he devised a scale, ranging from type 1 to type 3 to measure it. Type 1 means harnessing your entire home planet. Type 2 means capturing all the power of a neighboring star. Type 3 means mastering the energy of an entire galaxy. Now, this scale, and also Dyson spheres, type 2, are mostly cited in sci-fi and pop culture these days, but they actually appear in quite a few scientific journals as well. Okay, I hear you. Where are we on this scale? After all, we live in the age of supercomputers and humanoid robots and gene editing and cars that drive for you, and AI chatbots that know everything and totally don't hallucinate and make stuff up. Yeah, I digress. In order to answer that, first we have to skip forward a decade, from 1964 to 1973. That's when astrophysicist Carl Sagan got a hold of the Kardashev scale and modified it, basically so that we, humanity, could be on it. Sagan pointed out that the jump between levels was massive, so he suggested smaller subcategories, expressed as decimal points, so type 1.2, for example, or type 2.6. He also suggested that the scales start at 0 instead of 1, and that a civilization's progress through a given type could be represented with a letter in the alphabet. All that to say, drumroll please, according to Sagan's mathematical formula, humanity is currently at roughly a 0.73. Yeah, as in not even a type 1. A tad anticlimactic. But it's a lot less so when you look at the enormity of the entire scale. Achieving a type 1 means that a civilization can harness all available energy on their home planet. For us, that means using every bit of solar, hydro, geothermal, and wind energy on our entire planet. It also means building cities on top of oceans and controlling the weather to an extent that stopping natural disasters becomes possible. So yes, right now we can build megacities, though on land. We can mine the Earth for resources, and maybe soon the moon and asteroids as well. We can also create and remove rivers and lakes, and even alter our atmosphere. Whether we should, though, is another matter. Assuming we continue along the same trajectory, harnessing around 3% more energy every year, we should hit type 1 within the next 100 years or two, so a while from now. Earth intercepts about 1/billionth of the energy that our sun sends out into space. Right now, we can only make use of about 1/millionth of that 1/billionth. That's obviously nowhere near being able to gain total control over it. But the funny thing is, we've been imagining what it would be like to be able to control a star for a much, much longer time than Kardashev could have imagined. In Polynesian mythology, there's a figure named Maui. You see, Maui was a demigod and a major trickster. Anytime he noticed that the world worked in a way that he didn't like, he basically said, "Game on, we'll just see about that." There are a bunch of versions of this particular story, going from Polynesia all the way to Hawaii. But the general idea is this. One day, Maui noticed that the sun was moving quickly across the sky. So quickly that the people of his village had almost no time to get anything done. The days were so short that they struggled to work, gather food, or so much as eat a meal. Even the fruits on the trees didn't have enough time to ripen. Everyone was always tired and hungry. So he consulted his brothers and devised a plan. Weave a magic lasso using magical fibers, either locks of hair given by his mother Hina or stolen banana tree fibers, depending on which version you read. Then he would climb to the top of the tallest mountain, wait for the sun to rise, and snag it, hook, line, and sinker. Naturally, after it's captured, the sun pleads with Maui for his life and agrees to march more slowly through the sky in the summertime. That way, it would allow for more long days. And it would also move more quickly only in the winter. This way, the people of the Pacific Islands could enjoy rich harvests and enough time to feast after the day's work was done. But if that's how a mystical demigod would achieve a Kardashev Type 2, how might we do it? According to Kardashev, Type 2 means a civilization would be, quote, capable of harnessing the energy radiated by its own star. For example, the stage of successful construction of a Dyson sphere. Now, if you're not a sci-fi fan and haven't heard of a Dyson sphere, it's described as a megastructure built around a star to absorb all of its energy. The idea originally came from mathematician and physicist Freeman Dyson back in 1960, and in his main paper on it, he describes it as a shell, or a biosphere, that would encircle the host star. The main issue with this is, according to modern physics anyway, a structure like this would not be gravitationally stable. Meaning, if there was even the smallest movement or disturbance, its position would shift and it would just collide with the star that it surrounds. Not to mention, building it would probably require so much raw material that at least a few entire planets would have to be harvested to make this happen. Quite the jump from Maui's magic lasso, huh? But still, a reasonably close idea. Freeman Dyson later explained that he had something a bit different in mind when he talked about Dyson spheres. Quote, "A solid shell or ring surrounding a star is mechanically impossible. The form of biosphere which I envisioned consists of a loose collection or swarm of objects traveling on independent orbits around the star. That's where the term Dyson swarm came from later. If something like this were happening out there, it might look a lot like what we saw with Tabby's star. But worth noting, a lot of the same people who argue against the possibilities that unusual things in space could be caused by Dyson spheres, they make the point that by the time we reach a Type 2 civilization, we'll have come up with a much less fragile, much more resource and energy efficient way of harnessing a star's energy. But hey, to be determined, right? As for Type 3, this is where a civilization would have to harness an entire galaxy and be able to bend that galaxy to its whim. Every single piece of matter in our entire Milky Way would have to be made use of, which, by the way, is home to anywhere from 100 to 400 billion individual stars, and it's also 100,000 light years wide. This is literally a scale of energy beyond our comprehension, and at this scale, part of me wonders if we'd even still be human. There's one other part of Maui's story that I feel has a uniquely symbolic meaning in this discussion. Keep in mind, this demigod got up to all sorts of mischief in his day, but I think it's his last act that holds the most weight. Not so different from the Greek myth of Prometheus, Maui had the desire to grant ultimate power to humans in the form of immortality. He came up with an idea involving the goddess of death, and that while she slept, he would transform into a lizard and enter her body from the bottom up. Yeah, this is a super weird one, so I'm gonna let you figure out exactly what that means, but the idea was to reverse the process of birth. When Maui's father found out about this plan, he warned him not to go through with it, calling it absurd and blasphemous against the creation of life. But Maui does it anyway, and then he gets caught in the act and is killed instantly. In other words, the same figure who was great and powerful enough to capture and slow the sun could not overcome the final boundary. We often imagine progress as infinite, that with enough time, enough energy, we could overcome anything. But every culture that has imagined ultimate power also imagined a limit. Maybe we won't ever really know what's going on with Tabby's star. Maybe we're not supposed to. Or maybe, if we do, it'll be so far forward into the future that we won't even remember ourselves in the way that we are now. On the other hand, maybe the Kardashev scale isn't just a ladder. Maybe it's a test. A point where every civilization has to decide whether becoming more powerful also means becoming something else entirely. But what do you think? What's really going on with Tabby's star? Is there a gigantic cosmic dimmer switch out there somewhere, or is it something else entirely? And what's your take on the Kardashev scale? How long until we hit Type 1 or even Type 2? A lot of you guys reached out to me in the comments on previous videos asking more about the Kardashev scale, so this one was for you. In any case, I would love to hear your thoughts about all of this and more in the comments, and if you have an idea for something you'd like to see a future episode on, let me know. I listen, I promise. And of course, if you enjoyed this deep dive into mysteries, myths, culture, and science, please take a second to like and share this video. And if you want to see more, subscribe. I upload every Tuesday, and it really, really helps get the word out there. Until next time, stay curious. Thank you.